Hey guys, 13b now. So in 13b, we're mainly just looking at this kind of formula and how to transfer between these two forms because they do mean the same thing. So for example, with x to the power of 1 half, hopefully we already know or remember that x to the power of 1 half is the same as the square root of x. Now with the square root of x, a 2 would be there, but we don't normally draw that, and x is to the power of 1. Okay, now that one's reasonably easy to understand, I hope. But if I look at something like that, like off the top of my head, I have no idea what 2 to the power of 2 fifths is. But it might help me a little bit if I kind of change it between these two. All right, so let's just do that for these four here and see if we can get our head around it. So with the rule, we've got a fraction as our power. The top of the fraction is going to be the power of whatever our base is, and the denominator is going to be whatever root it is. All right, so if we look at this example here, we want to change this into kind of a root form. So we're going to have our root there, and it's going to be x. Now we can look at these numbers here. Now, whatever is down the bottom of your fraction, that's the sort of root it is. So we've got a 3, so it's going to be a cubed root, and the 1 there is going to be the power. So this here just means the cube root of x. Now again, you don't need to write that 1 there. Let's move on to the next one, b. Let's do the same kind of process. We're going to have our root, and we're going to have y. 3 is down the bottom, so that means it's a cube root. 2 is up the top, so y is going to be squared inside there. Next one, set up our root, put our base in there. It's a 5 down the bottom, so 5 root. I'm not really sure how else you'd say that. And the 2 is going to go in here, so that would be the same as 5 root of 4. So what times by itself? 5 times gives you 4. All right, now this one over here, we've got a negative power here. So I don't really like the negative power. Let's change this like we learnt before. We'll move this down, so it gives us 4 on 3. Now we can focus on this bit here. So we're still going to have our 1 up the top as our numerator, but we want to change this bit into our kind of root form. So 2 is going to go there. 3 is down the bottom, so it's cube root, and 2 to the power of 4. You could change that as well if you like, because we can work that number out. I'm just going to leave what it is for now though. Okay, so let's move on to some that are a little bit more difficult because it involves more things or more processes. So with these ones here, the first thing I'm looking at is this inside here is not the same as there. So the bases are different, so we can't just put these together. But I know that this to the power of a half is going to apply inside here, but I don't really know what to do with it when it's in this form. So I'm actually going to kind of go backwards to what we were doing before. I want to take it from this form, so from this form into that one there. Alright, so let me set up my space here. It's still going to be to the power of a half out there. Now, I'm going to have x as my base, and remember, we're going to have our fraction. 3 is down the bottom, and 2 is up the top. And over on the other side, we're doing a really similar thing. 5 is down the bottom, and 4 is up the top. Alright, so these two are the same thing. We've just changed the form a little bit. Now, with this form that we've changed it to, it makes it a little bit easier to apply these powers on the outside. Now remember, when we've got a power on the outside, we need to times it to the power on the inside. So we're going to have over here x to the power of 2/3 times 1 half. And then over here we'll have x to the power of 4 on 3 times 3 on 2. There we go. So I might just simplify each of these ones here. Okay, so we can now see that those bases are the same. Yeah. So now that the bases are the same, we can actually put these together. So we've got x to the power of 1/3 plus, remember our rules, 6 on 5. And if you put those ones together, you're going to get x to the power of, what is it, 6 on 15. There we go. So that whole thing there, we've worked out is the same as this here. We've simplified it. And you could simplify that fraction as well, actually. All right, let's move on to this next one here, though. This is our last one that we're going to do. All right, now, as we can see, this one would just be to the power of 1. And this one over here, we've got a square root there. So square root, remember, is the same as to the power of 1/2. So let's change it to that for now. Cool. Now what I can see is that this is the base here and this is another base here. They are the same. So because they're the same, we can kind of combine them together. So it's going to be 1 plus 1/2 for this one. So 2x minus 1 and 1 plus 1/2. I'll write it actually. So that's the power of 3 on 2. Alright, cool. So I might not just leave it like that. I'm going to change this into the root form. So it would be a square root. You don't really need to write that 2 because the 2 is down the bottom. Then 2x minus 1, and that's all to the power of 3 underneath there. Okay, so that would be how you do it. Alright guys, we're finished for 13b.